Hello everyone. In this tutorial I'm going to be talking about cost curves and the different types of costs that firms incur in production. We're going to be starting off by looking at a data set, and that data set's going to help us understand where these costs come from, what they represent, and their relationship to each other. And then once we're done with the data set, we're going to go down and we're going to plot out all of these various costs, and at that point we should have a better understanding of what those costs represent. Now, when I was an undergraduate, the first thing that we did is we drew the cost curves out. That is, we drew graphs. And I remember being a little overwhelmed at that moment in my life, and I thought, wow, I don't really understand what this means. Which is why I've taken the approach of first going through the data table and then looking at the graphs afterwards in the context of the data table that we had just gone through, and looking at them in some ways together. Now, there are two types of costs that we are generally going to be talking about. The first type of cost is what we call a fixed cost. So I'm just going to maybe write that over here. Fixed cost. And then the other type is what we call a variable cost. I'll use green. Okay, so you have fixed and variable costs. And fixed costs are costs that do not change with output. So let's say I owned a sandwich shop, and in that sandwich shop, I had a meat slicer and an oven and some things like that type of equipment. Now, no matter how many sandwiches I'm producing, I'm probably not going to have to buy a second meat slicer or a second oven. Those things are going to be what we call fixed. They're not going to change no matter how many sandwiches I'm producing. Now, variable costs are a little bit different. Variable costs do change with output. So that would be things like the meat, the cheese, the bread, the toppings, the lettuce, and the condiments and things like that. So variable costs do change with output. And then if you add the fixed and the variable together, you get what we would call the total costs. In the total costs, fixed plus the variable equals the total. So what we're going to be talking about, it's not just fixed and variable, but it's going to be the total fixed and variable and the average fixed and variable and average totals, and all of that sounds very confusing. So I've provided this cheat sheet so you can look at it in a few different ways. Notice that you've got a number of different relationships. You have relationships in this way where you have the total fixed cost and total variable cost equals your total cost. But then if you divide any one of those costs, say total fixed divided by the output that you're producing, that gives you your average fixed. Same is true with the total variable. You can divide that by the output and you get your average variable. And if you take your total costs, that is the fixed and variable combined, and divide it by the output, you get your average variable. And then of course there's a relationship this way as well. Okay, and this is sort of just the reverse. So what we're going to do is just sort of dive right in and understand these different relationships by doing. Now I want to start off by highlighting that there's a relationship here. Total fixed plus the total variable equals your total cost. So there's a relationship here to begin with. Then you also have a relationship here. Average fixed cost plus your average variable cost equals your average total cost. So there's another relationship here. But you also have relationships across. So the total fixed cost divided by the output gives you your average fixed cost. The total variable cost divided by the output gives you your average variable cost. And your total cost divided by the output gives you your average total cost. Now, traditionally, the curves that we pay the most attention to are going to be on the right-hand side when you're doing cost curves, but that's not necessarily always the case, but that's traditionally what we're going to be looking at if you're looking at, say, AP textbook problems, AP microeconomics problems. Now, the one cost that doesn't have as clear of a relationship is the marginal cost. Now, the marginal cost is defined as the change in the total cost divided by the change in the number of outputs. Okay, so we're going to dig right in here. So let's begin by noting that no matter how many units you're producing, your fixed costs are fixed, which means that they're not going to change. So even if you're producing 0 outputs and you have 0 variable costs, you're going to still have costs. So if the total fixed plus 0 equals your total cost, then we know that the total cost must start off as being 10, because 10 plus 0 is 10. Now the averages we can't really define because we can't divide by 0. Now if we go on to the first unit of output, the total fixed is going to be there no matter what, and it's always going to be the same. So you might go ahead and fill in all of these numbers, because the total fixed cost is always going to be 10, at least in the short run. Now, the total variable cost is going to change and the total cost will change. But notice that now we have additional numbers to work with, so to kind of sort out our puzzle. So 10 plus what equals 18? Well, that's 8. Now, the average fixed is going to be the same as the total fixed cost because we're dividing it by 1. So we know that the total fixed cost is 10. If you divide that by 1, it's still 10. Same is true with the average variable. The average variable is 8, going to be 8 divided by 1 equals 8. And then the average total cost, if we're dividing the total cost 18 by the output, 18 divided by 1 is 18. And the marginal cost is the change in the total. Notice that you see it right here. We go from 10 to 18, and that change is 8. Moving on to the second unit of output, 10 plus 13 equals 23, so we know what our total cost is. The average total or average fixed cost is going to be 10 divided by the quantity of output, which is 2. So 10 divided by 2 is 5. 13, total variable cost, 13 divided by 2 is 6.5. And then you could either add 5 plus 6.5 together, or you could take, to get the average total cost, or you could take the total cost and divide that by 2, which gives you 11.5. And you can approach this in either way. The marginal cost is, once again, the change in the total cost, and we see that the change is 5. Moving on to the third unit of output, we have a total fixed cost of 10, total variable cost not given, total cost not given. In fact, the only piece of data that we really have that's new is the marginal cost. So in order to do anything with this, we need to remember that the marginal cost is the change in the total cost divided by the change in the output. Now, we're always changing the quantity of output by 1 in this case, so we don't really have to do any dividing. We're just looking at that's the increase in the total. So the total is going to go from 23 and up by 3, which means that the new total cost is 26. So that's how we can solve this. And now we've got the missing data that we needed. 10 plus what is 26? 16. And then we have 10 divided by 3 is going to be 3.3. Average variable cost, we're going to 16 divided by 3 is going to be 5.3. We're not going to do all the decimals, so excuse the rounding. And we could add these two together, or we could take 26 and divide that by 3, and it gives us 8.6 approximately. And I'm going to go a little faster. 10 plus what is 18? Well, that's going to be 8, or 10 plus what is 28, rather, so that's going to be 18. So now we're going to have to take 10 divided by 4 is 2.5. 2.5 plus 4.5 equals 7. And the marginal cost is the change in the total. We can see that we go from 26 to 28. So that's plus 2, positive 2 that is. For the fifth unit of output, 10 plus what is, well, we don't know. We need to get some more information here. So the only information that we have in this particular case for the fifth unit of output is we've got the average total cost, which is 6.2. Now, remember that to get the average total cost, we take the total cost and then divide it by the output. The output, of course, is 5. So if we divided total cost by 5 to get the average total cost, then it follows that we could take the average total cost and then multiply it times 5 to get the total cost. Okay, so if we take 6.2 and multiply it by the quantity of output, which is 5, that will give us our total cost, which is 31. 10 plus what is 31? That's 21. 2 plus what is 6.2? 4.2. And the change in the total cost is 3, positive 3. Moving on to the sixth unit of output, 10 plus 25 is 35. And average fixed cost is going to be 10 divided by 6 is 1.6. And average variable cost is 25 divided by 6 is 4.16. Average total cost is going to be 35 divided by 6, or we could add these two together, and it's going to give us approximately 5 point, we'll call it 5.8. Marginal cost is the change in the total cost. For the seventh unit of output, we've got 10 plus what is 41? That's 31. Now we're going to divide 10 by 7. That's going to give us 1.4. 31 divided by 7, 4.4. And if we add those together, again we're rounding here, we can have 5.8. And if we were to look at the change in the total cost, the change in the total cost is positive 6. And the last unit of output, the eighth unit of output, 10 plus 39 is 49. 1.25 is given to us as the average fixed cost. The average variable cost, 39, divided by 8 is going to be 4.8. And we're going to be 1.2, let's do 49, we'll do it this way. There's a number of different ways to do this, but say 49 divided by 8 is going to be about 6.1. And then the change in the total cost, once again, is going to be the difference between 41 and 49, which is 8. Now the next part of this problem asks us to plot each of these curves below, but specifically it asks us to put the total fixed costs, the total variable costs, and the total costs on the left side, put the average fixed costs, the average variable costs, the average total cost, as well as the marginal cost on the right side. So I went ahead and plotted out all of the different costs, and on the left-hand side you have your total fixed costs, your total variable costs, and your total costs all plotted. And then on the right-hand side you have your marginal cost, your average total cost, your average variable cost, and your average fixed cost all plotted. Now most of the time we're going to be dealing with this right side rather than the left side. But having said that, let's first look at the left side and see what we notice. One of the things that you're going to notice right away is that the total fixed cost is constant. It's always the same. It's always $10. The difference between the total cost and the total variable cost is also always going to be $10, meaning that this gap that we see between the two is always going to be in the amount of total fixed cost. Now, on the right-hand side, you're going to notice that 3 of the costs have sort of a U-shaped behavior. That is, that they're going to start off higher, and then they're going to go lower, and then they're going to go higher again. The only cost that is the exception is the average fixed cost, which keeps getting smaller and smaller as we divide the average fixed cost over ever greater quantities of output. At this point, it would make sense for us to start answering some of the questions that came in this packet. First question is, explain the behavior of average fixed costs. Well, we see that the average fixed costs start off high and then they keep going lower and lower and lower and lower. The average fixed cost, as we mentioned before, is the only cost that's going to continue to decline as we go in and produce ever greater quantities of output. So that number is going to keep getting smaller and smaller. The next question asks, what is represented in the gap between the average total cost and the average variable cost? Well, the gap between the average total cost and the average variable cost is always going to be in the amount of the average fixed cost, meaning that these two curves, that is the red and the green curves, are going to get closer and closer together, and they're always going to happen to be the same as whatever the amount of average fixed cost is. One can see this quite easily when we look over here. For example, at 1 unit of output, the difference between the average total cost and the average variable cost is 10, and the average fixed cost is, of course, 10. If we switch to a different quantity of output, you can see that the difference between the average variable cost and the average total cost at 5 units of output is 2, and of course the average fixed cost is 2. So you're going to see these two numbers getting closer and closer together as the quantity is increased. So the next question asks us, why does average total cost have a U shape? Meaning, why does it start off high and then eventually go higher? Okay, for average total cost, and this is going to be true for average variable cost as well. Well, on the front end, one of the things that we're going to notice, and you can see this here with the average total cost curve, it's starting off high, going lower, and then it's eventually going to keep going higher and higher as marginal cost rises. So on the front end, we have high fixed cost. High fixed cost at low quantities of output. But on the back end, on the second half of the graph, we're going to start to see the law of diminishing marginal returns. Meaning that as you're increasing production, it's going to take more and more variable inputs to produce less and less of your outputs. So the next question asks, if marginal cost is below the average total cost, then the average total cost must be either increasing or decreasing. So what's the answer? Well, again, let's remember this rule about marginal. If the marginal cost is below the average total cost, then the average total cost is declining. Keep in mind this analogy of a marginal quiz. If I have 5 quizzes that have an 80% average, and then I take an additional quiz, and that additional quiz is lower than my average, that additional quiz is going to bring my average down. So we know that if the marginal cost is below the average total cost, then the average total cost is decreasing. But if the marginal cost is above average variable cost, which is a different cost curve, but it's the same idea, then the average variable cost is increasing. Okay, so decreasing for the, if it's below the average total cost or the average variable cost, but then if the marginal cost is above the average variable cost or the average total cost, then those costs are going to be rising. And then you can see that here. As soon as the marginal cost goes above the average variable starts going up. And as soon as the marginal cost rises above the average total cost, it starts rising as well. Question number 8 asks, marginal cost does not intersect with which of the following at its minimum point? And the answer there is the average fixed cost, because the average fixed cost by definition doesn't have a minimum point. It keeps going lower and lower and lower. And the last question is a slightly different question. It brings into the equation the revenue side. The rule for profit maximizing firms is that you should always produce where marginal cost is equal to marginal revenue, meaning that the additional cost of producing an additional unit should be equal to or less than the additional revenue that you receive from the sale of an additional unit. Suppose that each baseball can be sold for $5. How many units will this firm produce to maximize their profit? Okay, so one of the things that I'm going to recommend here is that you add an additional column. And I'm going to add this column, and it's going to be called marginal revenue. In the marginal revenue, we're selling 1, 2, 3, or 4 baseballs, whatever number it is, it's always going to be 5. Now at the low end, you might think, well, we want to produce here. No, you don't want to produce there. You want to wait till your marginal cost goes down and then starts going back up again. And so if the marginal cost is at, let's say, 3, that means that you're going to get, if you produce 5 baseballs, you're going to get $5, but the additional cost of an additional unit is only 3. That means you'll make $2 on that particular unit. If you produce another unit, the 6th unit, you're going to produce that unit at $4, a marginal cost of $4. The marginal revenue or additional revenue is going to be 5. So both of these would be worth producing. So one way to put this is that my marginal revenue is greater than my marginal cost. So these are all things that I'm going to want to produce, right? Where the marginal revenue is greater than the marginal cost. But when I get to the 7th unit of output, I see that the marginal cost is 6, but the marginal revenue is only 5. That means I'm going to lose $1 on that unit. So you do not want to produce that unit. So the answer here is that you would want to produce 6 units of baseballs to maximize your profit. Now that does not mean that you're actually making money. It simply means that you're minimizing your loss and you're producing at the profit maximizing output. And again, that profit maximizing output is mostly referred to in the following way, that you produce where your marginal cost is less than or equal to your marginal revenue. And at this particular question, with this particular question, you would want to produce 6 units. Okay, and that concludes this tutorial.